I think Samir already showed these. These are the GUIs we have. Now, come on. Here is another implementation we made. It gives you the opportunity to run a batch. That was also done in Mathematica. So you essentially, here is, what's pointer, you said? Okay. So we have here one, where here to load data, where to write the output. Then it's a CSV format, so it's a simple, plain text format, organized as a table. You load it, and then you can run all patients in one run. And here, this table gives you then all the patients you calculated, giving you information on the left side on the measurement, and then on the right side, what lens is the best one, so that you can see what to choose. Here we have chosen only one lens. You can get 5 results, 10 results, whatever is necessary, but typically a surgeon is used to a small number of lenses he's always using, so it doesn't make sense to generate a huge list of results. This Samir already showed. No, come on. What I here did is, we have now a C++ executable. And I want to make accessible as soon as possible, for example, a batch mode. Implementing this in C++ is taking some time. So what I do is I use Mathematica to call several times the C++, getting the output, and then post-process and generating a table from that. So first I pre-process here some CSV data. These are the patients essentially. That's a simple table. And then I run the calculation. Here's an executable. I created the C++ executable. I collect the output, post-process, and generate this table in Mathematica. So I get quick results, and later I can prototype like this, and later I can implement this in C++ after I've gone all these wrong paths that I'm not satisfied with. It's much quicker in Mathematica. And I can look as deep as I like. The C++ executable generates a lot of information. It's not necessary to have here any details, but to show you how many results are generated. So whenever you need more, you can have access to it. And playing with this in Mathematica is much faster than in C++. You just play with it, look at it, and then you decide what's the best for user. Another issue is to run what Samir said, to check if the formulas you use, the algorithms you use are correct or not. I prefer to use identical same C++ executable I later use for user. If I use Mathematica, do a copy-paste, put it in C++, there can be always a typo, whatever. I prefer to use exactly the C++ executable. Then I call it in Mathematica. I run through a whole bunch of values. And this, for example, is looking nice. But then this is now the power calculated for the lens, independence, essentially of the curvature of the eye. And you think everything is fine. But then if you look at the dependence on the length of the eye, that's the next graph, you see, oops, there may be a problem. On the left side for very short eyes, on the right side for very long eyes. So like this, you can see if your algorithms you're using are good. Another thing we use, for example, we have a formula to calculate the power of the lens. But later you want, after the calculation, know how much the patient is left with. So how well you really corrected. So you must solve the inverse problem. Typically, you use some numerical stuff to do it here, for example, with find root. But Mathematica can do better. So you can symbolically solve the equation, post-process a bit, and then you get here something you can paste a string directly in a C++ executable, no typos, because it's automatically processed. And One advantage is speed. Here it's about 30 times faster than the find root, obviously, because it's just a simple formula to use, no real algorithm to find a solution. But I think we're run a bit out of time.